Hello, my name is David Hazimi, and I am going to tell you about hypertrophy. Hypertrophy is a cellular adaptation. Cells adapt to their environment to escape and protect themselves from injury. An adapted cell is neither normal nor injured. Its condition lies somewhere between those two states. Adaptations are reversible. Changes in cell size, number, phenotype, metabolic activity, or functions of the cells. Adaptive responses have limits, however, and additional cell stresses can affect essential cell function, leading to cell injury. Cellular adaptation also can be a common and a central part of many disease states. In the early stages of a successful adaptive response, cells may have enhanced function. Thus, it is hard to distinguish a pathologic response from an extreme adaptation to an excessive functional demand. The most significant adaptive changes in cells include atrophy, hypertrophy, hyperplasia, metaplasia. Hypertrophy is a compensatory increase in the size of cells in response to mechanical stimuli, also called mechanical load or stress, such as from repetitive stretching, chronic pressure, or volume overload, and consequently increases the size of the affected organ. The cells of the heart and kidneys are particularly prone to enlargement. In slide A, transverse slices of a normal heart and a heart with hypertrophy of the left ventricle. L is the normal thickness of the left ventricular wall. T is a thickened wall heart in which severe narrowing of the aortic valve caused resistance to the systolic ventricular emptying. Slide B, a histology of cardiac muscle from a normal heart. Slide C, a histology of cardiac muscle from a hypertrophied heart. Hypertrophy can be classified as physiological or pathologic. Time be the critical factor or determinant of transition from physiological to pathologic cardiac hypertrophy. Aging, strenuous exercises, and sustained workload or stress lead to pathologic hypertrophy with structural or functional manifestation. Pathological hypertrophy in the heart is secondary to hypertension, coronary artery heart disease, or problem valves, and is presumed a key risk factor for heart failure. Historically, pathologic cardiac hypertrophy has been considered irreversible. Emerging data, however, from experimental studies and clinical observation show in certain cases reversal of pathologic cardiac hypertrophy. Cardiac hypertrophy can be reversed when the increased wall and stress is normalized, a process termed regression. For example, unloading of hemodynamic stress by a left ventricular assist device known as LVAD induces regression of cardiac hypertrophy and improvement of left ventricular function in those with end-stage heart failure. Thank you.